Here we have the completed hard drive Tesla turbine. Just to save time, I put the cover back on with foil tape, but basically it's all sealed up. The drive actuator, or the servo rider actuator port here, is my exit vent. My manifold goes in the copper tube, and internal you will have seen the how the manifolding was taken care of and the other stuff. I'll show you the bits. We're about to demonstrate the Tesla turbine running on compressed air. I've also been able to run it on steam pressure. And there I'm pinching the hose off. When I release the pinch, really hear the motor wind up. Turn off the air by pinching the hose off, and you can hear the hum of the Tesla turbine. The exit hole for the air is on the top at this point. It's the servo rider actuator hole. A little bit more air, we'll spin it up again. Not running the compressor because it makes too much noise, so it's just off of what was in the tank. And here we're running just about maximum speed. The disk drive motor works as a generator when it's running, so we're actually getting electric output out of this. It's not a very efficient generator because it's designed to be an extremely efficient motor, so that's just the way it works out. So the first part was to completely disassemble the hard drive. All the head gimbal assembly I throw out, all the magnets I throw out. I keep the spindle motor dry, or discs. It takes discs for probably at least 2 hard drives to make one Tesla motor, because the disk spacing is smaller. And anyway, I like this model of hard drive because it has a removable motor so that you can stack the disks up for machining, etc. It came in very handy in this case, and we'll be able to put the elements back in. The other nice things is it's very close fit around the perimeter, so when it's sealed up with the lid, the venting will be very tight around. Eventually I put some material here, some epoxy material to complete the encapsulation, and I have my input vent here, and the exit will be the servo rider actuator hole, which is underneath this tape on this second example of the drive. Anyway, we'll see it all in action pretty soon. The hardest part of making the Tesla turbine was getting the vent holes put in the disk drive discs. I had a friend do this for me who had adequate machine tools. We stacked all of the platters onto a disk hub, clamped them. He was able to take the assembly, clamp it, and rotate it. He managed to put 9 exit holes for me. I'll show you how this goes together later. Next, I'll show you how to make your own disk spacers. The standard disk drive spacers are way too thick to make the Tesla turbine effective, so you have to get the gap between disks much smaller. Here are some standard disk spacers. They would go on between disks to allow room for the disk or the head actuator and heads to fit in between disks. This type of clearance, however, is way more than is required for a Tesla turbine. To get the Tesla turbine spacing, we want about 6 to 10 mils spacing. A little bit more in my case. I'll show you how I reduce the spacing here. To make my own disk spacers, I tightly wind some copper wire around a spark plug socket. I'm then able to cut these winds and get some flat spacers like C-ring spacers. There's some wind around the socket, and there's the spacers after I've cut them with a pair of dikes. Okay. I used a socket that was slightly smaller diameter than the hub of the spindle hub for the hard drive. That's so that I'll have a slightly positive inward tension and they won't slip around too much. Put the spacer on, spindle between the individual discs, and then slide disc on and another spacer, and another disc, so on until my disc stack is complete. This is partly finished, but you can see that it gets considerably tighter spacing than with the standard disk spacer from the hard drive. I use the chopstick to keep the vent holes in alignment. I biased them slightly to one side. Not certain whether this has a positive effect or not, but I thought the airflow might want to be able to get from one exit hole to another exit hole. The final disc in the stacks without a spacer, and I use that basically to seal the vent holes on the top surface. I want it to vent out the bottom because that's where the drive casting in this case had its exit hole. Here we have the modified drive casting with the disc spindle removed. And here, looking at the top of the disc spindle, you can see on the top I've aligned the holes to be plugged. There's the clearances between the discs. The top two have no clearance, there is no spacing, and all the others have some spacing, and the holes are aligned such that the air from one disc will go down to the next. This allows for fast and efficient running. I'll make one more demonstration of the Tesla turbine running with the cover off, where you can actually see the discs spinning because of being able to see what's going on. On compressed air. Here. Pretty speedy unit.